All right, guys, quick review today about solving inequalities. So it's really something you've done for a couple of years now, and we're going to add to what you've already learned just a little bit, but for the most part, it's just going to be a review. So remember, inequality looks just like an equation, but instead of an equal sign right here, we have an inequality sign, either the greater than or the less than sign. So to solve these, really, we just do what we do if it was an equal sign. I need to get a by itself. So to do that, I'm going to add 34 to both sides. And 9a is going to be greater than, I leave that sign the same. 9a is going to be greater than 38 plus 34, which is 72. And then when I divide by 9 and divide by 9, a is greater than 72 divided by 9 is 8. So a can be a lot of different things, and that's one of the biggest differences. Instead of a just equaling 8, a is a lot of numbers. It's anything that is bigger than 8. So when we graph that, we graph it on a number line. And what we really, there's two numbers that I care about on your number line. The first number is I want you to mark 0. You need to show me where the 0 is. The second number is whichever number obviously we're dealing with here, which is 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to go over to 8. And I'm going to mark those two on my number line. The rest, I don't really care about. Those are the two I'm concerned with. So when you're graphing this, if there is, remember, if there's no line underneath, then we put an open circle at that number. We're going to put an open circle right at 8. We're not going to put it above the number line. We're going to put it right on the number line. Right at 8. And a is greater than 8. So I'm going to draw an arrow either pointing to the right or the left. If you can't remember which way to point it, look at your equation, your inequality here. My inequality looks like an arrow pointed to the right. So when I graph this, I'm going to make, maybe we better use another color other than blue. When I graph this, I'm going to graph it with the arrow pointing to the right, because a is all of the numbers that are bigger than 8, and it doesn't include 8, so we have an open circle. Okay, so same idea here. 3a minus 7 is less than 32, so I add 7, I add 7. So 3a is less than 39. Divide by 3, so a is less than 13. Again, on the number line, I care about two numbers, 0. So 0 can be right here, and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, it's an open circle because we're not including 13. So it's an open circle, and this time my arrow's pointed to the left because a is all the numbers that are less than 13. So it can be 12, 11, 10, 9, 8, all the way down to 0, even my negative numbers. All right. Couple more examples, and then I'm going to just give you some time to practice. Sometimes, just like with equations, there's a little bit more work involved. Here, m is inside the parentheses, so I can't solve for m until I get it by itself. So I'm going to distribute, first of all, that's 6. So 6m minus 30 plus 5 is less than 35. I'm going to add this negative 30 and the 5 together, just combining like terms. So 6m negative 30 plus 5 is negative 25, less than 35. Right? So now to get rid of this minus 25, I'm going to add 25 to both sides. So 6m is less than 25 plus 35 is 60. And then I divide by 6. So m is less than 10. Now, the only thing that we really need to be careful of is if you are dividing by a negative. So for example, in fact, let's go back. Let's change this problem a little bit. Instead of using these numbers, because we've done a couple examples with positives involved. So let's change this a little bit. Let's make, let's go ahead and make this a negative 6 right here. So I'm going to do what I did before. I'm going to distribute. Negative 6 times m is negative 6m. Negative 6 times negative 5 is a positive 30. Plus 5, less than 35. So 30 plus 35, or 30 plus 5, excuse me, is 35. So negative 6m plus 35 is less than 35. Now I'm going to minus 35. I'm going to minus 35. So negative 6m is less than 0. Now I've got to get rid of the negative 6 by dividing by a negative 6. And here's where we need to be really careful, because if I either divide by a negative or if I multiply by a negative, there's an extra step that we have to remember, and that's that this sign needs to flip the other way. So when I divide both sides by this negative 6, I need to change this sign. So it actually becomes m is greater than 0. 0 divided by negative 6 is 0, instead of m less than. So if you divide, multiply by negative, remember to flip that sign and point it the other way. In this case, I only have to include one number because the number that I want is 0. And I'm working ahead of myself just a little bit. At 0, I'm going to put an open circle because I can't be 0. If this had a line underneath it, I would put a closed circle here, but it's an open circle. And my arrow is pointing to the right because m is bigger than 0. So again, I'll do this in yellow just so you can see where it's at. But my arrow on my number line would point to the right. Again, please draw this on the number line. Back in 7th grade, 8th grade, 9th grade, a lot of your teachers were okay with you putting the circle up here and drawing an arrow above the number line. That is not correct. You need to be right on top of the number line. And I know that drives some of you crazy to draw a line on top of another line, but get over it because that's the correct way to do it. Okay, 2 situations to be careful of. As you're solving these, sometimes, in this case, 7x minus 15 is less than 7 times x minus 4. So I've got to distribute that x. And 7 times x is 7x. 7 times negative 4 is negative 28. So 7x is less than, or 7x minus 15 is less than 7x minus 28. I want to get my x's together. So I'm going to minus 7x, minus 7x. Negative 15 is less than negative 28. My x's canceled out, and I'm left with a statement that is false. Because on the number line, negative 15 is actually greater than negative 28. This is false. It's not true, which means that 7x minus 15 is never less than 7 times x minus 4. It is not true. It's a false inequality. There is no solution. Okay. The other thing that can happen, 5x minus 8 is less than, if I distribute this 5x and 5 times 4 is 20, when I minus 5x from both sides, again, my x's go away. So negative 8 is less than 20. That is true. So what that means is that this inequality is always true. There's no x value that you can plug in where it's going to be false. So it's always going to be true. So if the x's or the y's or whatever letter you have cancel out and it's false, that means it's never true. It's not true. If it cancels out and you're left with something that is true, if the x's go away and you're left with a true statement, then that means that the inequality will always be true. All right. Okay, couple more examples here. This is kind of what might be a little bit new. You've seen it before, but you didn't practice it very much. What if you're given 2 inequalities together? So in this case, 3x is greater than or equal to negative 15 and 7x is less than or equal to 21. So I don't just have one statement, I have 2 of them. A lot of what you do is the same. I'm going to get x by itself by dividing by 3 over here. So x is greater than or equal to negative 5. And on this side, I'm going to divide by 7 to get x by itself. So x is less than or equal to 3. So I have 2 statements. X is greater than or equal to negative 5 and x is less than or equal to 3. So let's graph each of these. X is greater than or equal to -5. So let's make 0 right here in the middle. And I'm going to go down to -5. 1, 2, 3, 4. Here's -5 right here. And if I graph this first one, I'm going to put a circle filled in right at -5. And my arrow is going to point to the right. So there's my graph for X is greater than -5. And X is less than or equal to 3. So again, here's 0. I'm going to go up 1, 2, 3. I'm going to fill in my circle because it's less than or equal to. And X is less than 3. So this arrow is going to point to the left. Okay, this arrow right here. And I know I'm going above the line just a little bit, so that's so you can see it. So X is less than or equal to that 3. Here's where we need to be careful. The AND statement. This is going to be my final graph down at the bottom. Here's one of my things that has to be true. This graph. This one also has to be true. So I have to pick the parts of the graph that are true for both of them. In other words, if I start here at -5 and I go up, I only can go up to 3 because on this graph, I stop at 3. And if I go to this graph and start moving to the left, I have to stop at -5. I have to stop right here because this graph doesn't go any further than -5. So my final graph, I'm going to put a filled in circle at -5, and I'm going to put a filled in circle at 3, and my graph is going to be what's in between them. My graph is going to be this section right here, because my graph has to satisfy the AND part. It has to satisfy both. So this part of my graph isn't true, and this part of this graph isn't true. The only part that's true is what's in the middle. Now, another new thing, or I guess newer than what you've been doing for a couple of years, is if it says the word or. And in this case, start out the same way. Get X by itself, divide by 7. X is less than or equal to -3. Or if I divide by 6, I get X alone on this one. X is greater than or equal to 30 divided by 6 is 5. So my inequality has to satisfy either this one or satisfy this one. In the last case, it had to satisfy both of them because of the word and. This had to be true and this had to be true. So I had what was in between them. In this case, I have the word or. So let's graph these first. X is less than or equal to -3. So here's 0, 1, 2, here's -3. I'm going to put a filled in circle there, and I'm going to draw my arrow. We better do this in yellow. That last graph was kind of hard to see. My arrow's pointing to the left. I'm less than -3. Okay. Or X is greater than or equal to 5. So again, here's 0. Here's 1, 2, 3, 4, 5. I'm going to fill in this circle because it's a greater than or equal to, and my arrow is going to point to the right. In this case, these two graphs, these two never overlap. There's never a point where they're at the same place. And that's actually okay because of the word or. This inequality needs to be true. Or in other words, this graph needs to be true. Or this graph needs to be true. So instead of taking the part of the graph that is the same, we just combine the two graphs together. So 0 is still right here in the middle. But my graph, I'm going to put -3, and I'm going to draw an arrow pointing to the left. I'm going to put this graph on here, and I'm also going to put this graph because it doesn't have to be both. It has to be one or the other. So I draw both of them on the same graph, and that would be my final answer. That's what my final graph would look like. So if it has the word or, you should have two arrows pointing in opposite directions to satisfy each of them. If it has the word and, you shouldn't have arrows at all. It's going to be a part of the number line that is in between the two graphs. It's what the two graphs share because it has to be true for both of them. All right. All right. So as far as the homework goes, we're skipping homework 17. So you have, yellow is awful. You've got homework number 18. A lot of you I know are gone today. You're at the football game. You're out of town. But this is still due next Tuesday. Okay. You need to have this done by class time next Tuesday. We'll go over it as a class a little bit, talk about some of the things if you have questions. Other than that, good luck. Email me if you need help.